So let can see the some demo that I prepared for you. So first of all, this is some of my sometimes my personal work or my interest. This is the problem we want to resolve this one is that we have some rectangle, and then the rectangle need to be sometimes they override each other, but we don't want to override, so they push each other a little bit. So we can customize the parameter, like an offset value, maybe less offset or big offset. For this is some iteration. How many, I guess, Do you know how can I create it? Nothing special. I already told everything to you guys, I create a vector and color, and then encapsulate in the other class, and then I decompose like a rendering part and an algorithm part. And then in the algorithm part, there's multiple steps during the iteration. The first iteration, checking if they check, and then what is your vector, and then compare, and then we can figure out the direction, and then I move a little bit, and then checking again because I move it to other place. Sometimes I can override other point. So I need to ask them, you need to go away. You know what I mean? Things like that. This kind of the thinking process. Human being can think easily, but most important thing is how we explicitly create the instruction for the computer using TypeScript, for example, here, right? So this is the other sort of circumstance, like we have like a black area that is like never moved, And this is like an iteration in optimization things. If you have a better idea, you guys can create a way better strategy, I guess. This is something I just thought about at the time, And this is other sort of implementation, because there are multiple ways to optimize the position of the rectangle. At the time I used the graph system. The previous one is let's say the agent base. So also there's some like very light simulation. Light means like a very fast performance. The simulating things called the spring system. So it looks complicated, but my understanding of the spring system is like there's some rule that we need to pursue, For example, the distance. 2 points has a particular distance. So while they optimize, sometimes the distance is a little bit closer, and then they try to push each other, pull each other, based on the previous calculation. So then we can make they're trying to maintain the exact same value because they're trying to offset, in order to make the same distance during the iteration. So this is the let's say very let's say, how can I say, just simple description of the spring system. Anyhow, let me close it. So we can actually apply this sort of thought to the optimization things. Kangaroo, right? In Rhino, Grasshopper. I have no idea, but probably they use the similar things. So we can actually, can like drag, and then the spring system, they try to keep like compute. Basically, we play with the environment, and then the individual geometry is like a compute based on the environment that we are tweaking right now, right? So we can play with it a little bit. Also, so there's something. It's nothing special. But what I'm saying is, again, so this looks complicated. But how we decompose the individual like rendering part or algorithm part or update part or iterated part or the if statement part. So we just think about in the concept of the class, that we learned today, okay? And this is the other implementation in the 3-dimensional area. So, so we can tweak it and click it and drag it. They're trying to maintain based on the variable. I use the 3JS, which is also we can learn in the web browser. And then we can go quickly. And then this is also the graph system. Graph is really important data structure to capture the spatial information. So you can use whatever like a network analysis using the graph. So in this case, I'm just making some playground. So if you click it, they actually try to find the closest point and then append the other point within particular the length. So that's why they push the exist point in that graph. See, like this. So, I mean, you can create your own sort of algorithm here, or you can click and dragging. I mean, you know, the yellow means they have some problem. Yeah, yellow means so that they're trying to compute based on the instruction that we already pre-built inside of the class. Yeah. Yeah, we can play with the length and then dragging or click. Or, I don't know. Yeah, just using the class, just play with it. And then also we can mimic sort of like a rigid body system. So here we have a gravity and then pull each other. There's just some weight and they're trying to like working based on our instruction. So for example, I can click and dragging. Yeah. I mean, again, I use the class and then decompose and then create the algorithm step by step. And also in the JavaScript, we have really good library called Meta.js. So this is really great and super faster, yeah, for the 2D collision things. So if you guys are interested in, visit this site, and there is documentation. There's a lot of like useful function that you don't need to worry about it for the implementation. So there's really one example for this method here. So we can just click it. We can keep populating some, just like a Tetris. It's nothing special. I just implemented like a Meta.js. But just as a designer, we need to think, right? How we take advantage of what kind of parameter we can assign. We can represent our design strategy in that physical engine, for example. Yeah, so I don't know, just for fun, maybe, yeah. And also we have the other block here. This floating. Just think about it, right? I'm playing right now. So this is the just very simple example, how we, dealing with the individual geometry as an agent, and then give some environment. Yeah, it's a really simple one, just for the exercise. And then this is one of my just when I have time, I'm trying to learn like a sort of like reinforcement learning. And then there's two things. One is optimization to make a win. But again, this is right now, I have not enough time to play with it. So, I mean, what you can do is we can think about like a space, individual space is like each pixel. And then how we packing the geometry, packing the geometry inside of the pixel. I mean, this is all about the Tetris, right? It's nothing special, but one day I'm gonna complete. But right now, it's not that complete things. And also we have the other things like here. This is actually one of my projects because one of my professors asked me when I was in Korea. So for example, we have a path route here, right? So individual is like a people try to evacuate, and then they need to wait, yeah. And then other pixels go, then other one is follow, and they have their own sort of the speed, and they also need to maintain the distance between them, yeah. Nothing special. I'm just think about the logic and how we decompose, how we make an instruction for that class or object. And here, what is this? Okay, let me click. Okay, so individual, the agent, there's room around. They sometimes stick each other. It's nothing special. I mean, this is the void and void simulation. There's a lot of example or exercise out there. For the implementation side, again, we need to decompose. Otherwise, we couldn't deal with the complexity. It kills us basically. So we have the other behavior. Okay, let me see. They actually try to follow my mouse cursor, but when they collide each other and then they literally step back a little bit, yeah. This is just something for fun for me. Again, we're dealing with the data, right? So this is the sort of the linear regression that you can directly learn on the web browser. As I said, like use TensorFlow. So I used some data from the TensorFlow, I guess. I couldn't remember because I did it a long time ago. But the interesting thing is that you can actually populate your own data here. And then can you see the fitting line here? Yeah. So think about it. We have a graph. Yeah. Individual graph has their own sort of linear regression to fit their graph. I'm just talking about the neural network basically. So what I'm saying is if once you are understanding or get familiar with the low level coding and then how we looking at the problem and then decompose and isolate the function and problem issues. I mean, this kind of the habit is really important for the computation designer, I think. Just my think, I don't know. Yeah. Just from my experience. So we have here, once you keep populating a point, we have also polynomial things, which is nothing special, which is keep training on the fly. My browser is getting heavy and heavy. Let me close something. Okay, so the last one, we have a multiple, like a linear regression, for example. I just draw 2 points here, right? However, they have like 4 different models to fit, to find the coefficient to describe the 2 points. What if I have one more point here, right? They try to fitting the given data to create a model that we can use in the future, for example. So what I'm saying is that we actually take advantage of this kind of, they are overfitting right now. Can you see that? So anyhow, so we have multiple polynomial sort of a model to apply to see what is the best model. And then we can actually deploy the individual agents that they have their own, like the degree of the polynomial, and they try to, I don't know, maybe compete or help each other to achieve some design problem that you already, describe in the function, for example. I mean, there's all freedom is there. So let me click here to become crazy. Okay, anyhow, so just close it. The last one, so I use TensorFlow here. So for example, if I open the kernel here, so I can draw like circle here. Yeah, circle. No, 1.9% probability that this is circle. What if I draw like a triangle here? Yeah, 1.9 trigon, and 1.00 probability like looks like cloud, and then a low text heart. Let me draw heart here, for example. Oops. Yeah, curve, they detect curve because I just double click on my mouse. Heart, yeah, pretty good. And oh yeah, yeah, singular row. What else? Maybe rectangle here, right? Rectangle, yeah. So I mean, I just simply use the TensorFlow, the machine learning things to training. I mean, but you know what? The most important thing is that what the network does, but for the designer, I guess, is how we prepare the data structure, yeah, to train the network. So I use the dot product for this, and then because sometimes I can draw the rectangle really quickly. Sometimes I can draw rectangle really slowly, like that. Yeah, see. I mean, we need to prepare this kind of how we capture this difference as a data. This is really important for the particular designer looking at the machine learning, okay? So this is the example things that you guys can, I'm basically encourage you guys like how we think about how we migrate, translate our design experience as a computation designer. There's a class concept, yeah, an object and function, yeah, and then there's a tool. What should we do, right? So trying to think about how I migrate my experience and my intuition as a code. Yeah. Class is there, object is there. They actually really useful friends to you. Okay.